So hopefully we got on all right with plotting those scatter graphs. Here we're again going back to that first one. So remember we said before we're looking for some sort of relationship, and I refer to the point for this one. These kind of make a general shape. So we're generally seeing that as the math score goes up, as that increases, the physics score increases as well. Now we need to get some terminology in here to describe this sort of relationship. So going back to the examples early on in the last video, the temperature outside and the ice cream sales, and we said that these were probably connected. I would expect, please make sure you're writing this, I would expect, like for example, this to really be if I had this, the temperature down here and the sales here, I would expect something along the lines of this. All right. So please write this down. As one value increases, so does the other. This is a positive correlation. Okay, positive correlation. So you need to know that vocabulary. This is a positive correlation. So if one goes up and the other goes up, so if they generally make this sort of shape here, that's a positive correlation. So here's the next one, temperature outside and hot chocolate sales. See if you can do what we wrote up here. See if you can do the same for this one. So we should have got something along the lines of the following. So this would be how the scatter graph would look. We would have, again, the temperature down the bottom, and we've got hot chocolate sales here. Now, if it's a low temperature, I'm going to have a high sales, possibly of hot chocolate. But as the temperature increases, we would expect the hot chocolate sales to be low. So let's just imagine that this is kind of what the data did here. All right, so I'm sure you can probably guess, or probably have hopefully written it down already. So here, as one value increases, so that's the temperature in this case, the other decreases. So in this case, the sales. And this is a negative correlation. And finally, so here we've got height and math scores. I don't know if you remember, but we said, look, if we had this here, so we've got height here and score here. Really, I wouldn't really expect, so there might be some tall people who do well, but there might be some tall people who do poorly. There might be some middle height people do fine, but some middle height people do well, but some do poorly. So really, I'm expecting it to not really show any sort of pattern. So here, we just say there is no correlation. Because whereas in that first one, they kind of all bound in this kind of shape, and this one, they generally bind in this kind of shape. So there's some sort of clear correlation going on. Here, there's not. There's no shape I could draw a bit like that. There's no line that kind of fits it for all. So quickly, just again, sketch these in the graph. You don't need to use a ruler, you can just do line, line, and then just roughly draw each one. And then what I want you to do is match up each one with one of these signs under here. So pause the video and see if you can match up what these are. Okay, so hopefully we've got the following. This first one here, well, we can see that these kind of pair up. So here and here kind of are the same kind of thing. Here and here again are the same kind of thing, and this one in the middle is kind of on its own, and we can see that's the last one we talked about here, that there's no correlation there. There's no sort of connection between those two variables. for the two green crossed ones, well, they're both showing as one increases, one variable, one thing increases, the other thing increases as well. So if you remember, these are both positive. So next one of these, well, these ones are far more close together. And so there's like a really strong relationship between the two. Here, there's still some sort of relationship, but it's a bit weaker. And by the same reasoning here, we've got a weaker positive correlation. However, this one is much stronger. We could almost draw a line through them quite there, and that would almost go through all of them. Whereas here, we could still do some sort of line, but it's just a bit not as accurate. So for each of the scatter graphs you just drew, what I'd like you to do is write this sort of sentence next to it. This shows A, and then we're going to use those descriptive words from the last slide. So for example, for this one, we said that it's positive. It's not very, they're not all really together. They don't make one really nice strong line. So we would say this is a weak positive one. This shows a weak positive correlation. So can you pause the video and do the other 4 that you've done? And then restart the video once you're ready. So this one, as one of these values, we kind of have done this already, so that we've got the value and the age. Well, here there is and I would say there is quite a strong negative correlation. Okay, because as one goes up, as the age goes up, the cost goes down. Negative correlation. And I'm saying it's strong because I can almost draw a line all the way through. They're really packed tightly together around one relationship. Here, right. Is there a correlation? There's not. I would say just about, but it's not very strong. So I would say there is a weak, potentially a very weak positive correlation, but there might be some argument to say there's no correlation. I probably could use a bit more information really. I might do a little bit more experimenting, get a little bit more data, and it might tell me a bit more. Because then if I get some more values around here and here, then I'll go, okay, yeah, that's far more of a positive correlation, and maybe this one is an outlier. However, I haven't got that information, so I'm just going to have to say for the time being, there's some sort of weak positive correlation. And finally, so here we have got, again, it's a bit more tightly packed than that last one and the first one. So I would say there is and I'm going to say this is quite strong. Positive. Alright, I could probably maybe have said there is a reasonably strong positive correlation, because it's not quite as strong as that negative one we saw earlier, but I can still use to draw some sort of line which they're all really pretty quite close to it. Okay, so that's correlation. So the last thing we want you to think about today is this question. Right, so Joe has a math test today. He says, I'm going to do well in this test as it's been raining this week, and I always do better in tests when it's raining. Does this mean that the rain causes him to do well in tests? So have a look at that scatter diagram, pause the video and think to yourself about that question. Well, hopefully we've had time to have a think about it. Now, this graph the scatter diagram generally suggests that he might be right, because the greater the rainfall is, the greater his test results are. However, let's use our common sense here. Does the rain cause him to do well in test? Well, no. There's probably something a bit more to it. It may mean that obviously if it's raining more, he's inside, he's at home, and he might go, well, I might as well do some revision. So it's probably more likely to be something like that. But the rain itself does not cause him to do well in tests. And this is a really important part of statistics. And I'd like you to write down this sentence. correlation does not imply causation. It's a very famous saying in mathematics. It basically means, look, these results, I mean, we know that when it rains, it doesn't magically cause us to be to do better in our tests. This has shown that there is some sort of connection going on, and it's probably worth doing maybe a bit more investigation about it. There is a very famous example of this, which basically said in a news headline, as the number of ice creams sold goes up, the numbers of murders increases. Now, funny enough, there is bizarrely some sort of correlation with this, and some people did this survey, but you can imagine that obviously the amount of ice cream that gets sold does not necessarily mean that the number of murders increases. There's no cause and effect there. The ice cream sales do not cause more murders to happen. As it happens there, both of these increase as temperature goes up. Not by massive amounts, but obviously ice cream sales go up massively, but the number of murders increases as temperature increases. Generally speaking, there's some sort of correlation there. Again, we would have to look into a bit more depth. But it's this key information bit here. Correlation does not imply causation. Even though there's some sort of pattern we can notice emerging, we would need to do a bit more investigation to work out what that maybe is.